slides, and today I uploaded chapter 2, naming rules. So download this file, and we are going to go over the naming rules for ions and different compounds today. So. All right. Naming rules. Well, I have to say that this is a part that will require you to do some memorization, and that starts from knowing the names of different elements, and from there we derive the names for ions and compounds. So first of all, actually some of this I have covered in the lecture I uploaded on Friday last week. Let me see if I can just, no. I'm trying to figure out if I can directly write on this file some technical. Here we go. Can you see my drawing? Okay, perfect. So naming rules. First, we are going to see how to name ions, cation and anion. These are pretty simple, especially for the cation. So for cation, just write down the name of the cation followed by ion. What it means is just write down the name of the element. For example, you have all these examples over here, like hydrogen, ion. So the name of the element is hydrogen and just followed by ion. This is a simple rule for cations. And second sentence is that if the cation can have more than one possible charge, write the charge as a Roman numeral in parentheses. And we show you the example last class. For copper, like copper, you can have copper 1 and copper 2. In order to differentiate them, you then just put this number within the parentheses, and when you read it as copper 1, and here is copper 2, and same thing for iron 2 and iron 3. Iron 3 is on the bottom here. This is iron 3. Make sure you don't forget to write down their charges. You only need it if this ion can form different charges. But if for example, in the sodium or potassium, they can only carry one positive charge, then you don't need to write down the number. Third rule, if it is a polyatomic cation, it will end in IUM. For example, ammonium ion, IUM, right? That's all for cation, the simplest one. Next one is anion. If the anion is an element, change its ending to IDE. So this time, again, they're derived from their element name, but you have to make some changes to the ending of the name. Then we introduced already, table 2.5, some common anions, right? So you change its name, this is fluorine, and you change it to fluoride ion. And what you can help you remember it a little bit better is to write it down yourself. Like, what is the name for this? Is from fluorine to fluoride ion, right? And just do the same thing for the rest of them, and that will help you understand it and memorize it, what it means. Second rule, if the anion is a polyatomic ion, what are polyatomic ions? Those ions that with multiple atoms in it, right? With multiple elements and multiple items, and follow the rules on the next page. Okay, now let's go to page 2. We're done with page 1. Now let's go to page 2. Naming rules for polyatomic ion. And usually they call it oxyanion. And the reason is because oxy, as it indicates, something related to oxygen, right? And if you look at all these polyatomic anion over here, they all have one thing in common, is that they all contain oxygen atoms in them. So they're also called oxyanion. Okay, and they have a general formula which look like this. That Z minus, it's actually should be here, that indicate the charges, superscript. And the naming rules here are, the most common form ends in ATE. And you can see plenty of examples over here. Acetate ion, ATE, chlorate ion, ATE, nitrate. These are the ones that you're required to know. Nitrate ion, carbonate ion, sulfate ion, phosphate ion. And again, they are derived from their element name. For example, P itself is phosphorus, right? And we change the ending to ATE, it changes to phosphate ion. Again, write it yourself for all these elements, from sulfur to sulfate ion, right? So that is the most common form. Then you may ask, how can I tell which is the most common form, right? Well, the ones that are given here that end with ATE, these are the common forms, and these are the common ones that you need to know. It's also given in this table over here. And this is taken out from the where they are in the periodic table. So you have carbon in group 4A, period 2, and CO3 2 minus, carbonate ion. This is a very common form. Nitrate ion is common form, and phosphate, sulfate, and perchlorate. And perchlorate, this is actually slightly different. And this, let's take a look at the rest of the naming rules. Okay, second rule is that the one with one fewer oxygens ends in ITE, and the one with the fewest oxygens has a prefix hypo and ends in ITE. The one with the most oxygens has a prefix per and ends in ATE. Okay, pretty confusing over here, right? And to understand this, you need to go to this figure. So to understand this, what you need to go do is to go to this figure or table over here. All right, so we start from the most, these are all the oxyanions that form from chlorine and oxygen atoms. And the most common one is ClO3 minus. Because it's the most common one, therefore simply it's derived from chlorine and its name is chlorate, ends with ATE. And then we apply the rule. What does the second rule say? The one with one fewer oxygens ends in ITE instead of ATE. So from ClO3 minus, one fewer oxygens, that would be ClO2 minus. And in this case, we change the ending from ATE to ITE, so chloride. Rule number 3, the one with the fewest oxygens has a prefix hypo and ends in ITE. Basically, you keep going to the right side of this chart, right? And then one fewer oxygen from ClO2 to ClO, and then we keep the ending ITE and add a prefix hypo, so hypochlorite. Rule number 4 is the one with the most oxygen, has a prefix per and ends in ATE, which is the one with the most oxygens. Then you go to this end of this chart, right? And so it follows the name of chlorate. So keep the ATE and add per, indicating you have one more oxygen. So this is the naming rule for polyatomic anion. And the one that you see in this chart is pretty much what you are going to be tested on for these 4 rules. And you also need, of course, you also need to know the common anions, the ones in bold in this chart, in this table, and the previous 2 tables on page 1. Okay, so this is not the most exciting thing of this class, but I do want to go over it so you understand what each of this rule mean over here. Actually, after class, you need to go over this document a few more times on your own. All right, so we finished anion, cation, and then we have anion and cations combined. What do we get? Ionic compounds, right? Then how do we name the compound? So name of ionic compounds consists of the cation name followed by the anion name. For example, calcium chloride, right? Name of the cation is calcium ion. Name of the anion is chloride ion. And you combine these two together is calcium chloride. And same thing, aluminum nitrate and copper 2 perchlorate. So the first one is easy. The cation is easy. The anion is a little bit complicated. And here, actually, first example is the simplest form that you have just a simple monatomic cation and monatomic anion, and that is simple. Let's combine them together, right? And the second one is example of a monatomic cation with a polyatomic anion. And then you need to remember, okay, NO3, 2 minus, that is called nitrate ion. The last one is an example where the cation can carry different charges. In this case, don't forget to put number 2 over here in parentheses. So copper 2, and the name of the anion is perchlorate. So copper 2 perchlorate, ClO4, with the highest number of oxygen, so ending ATE and start with PER, per, right? So that is the naming of inorganic compounds. And moving down, we have naming for acid. Actually, we haven't talked about acid yet. We are going to talk about acid-base reaction in this class later on. But for now, here we just define the acid with a compound that start with hydrogen, right? So over here, under this context, we just define it as a compound that if you dissolve it in water, it's going to dissociate into hydrogen ion plus an anion in water. So their chemical formula starts with hydrogen. And if you look at this hydrogen ion over here, it has a pretty interesting structure. So hydrogen element or hydrogen atom on itself, it has only one proton and one electron. It doesn't have any neutrons. And when it becomes a cation, it will lose its only electron. And the only thing left in that ion would be a proton, right? And therefore, sometimes we call this hydrogen ion just proton, because that's all it has, just a proton. Okay, so the naming rule for acid is that if the anion in the acid ends in IDE, then change the ending to IC plus acid and add the prefix hydro. Okay, it's a long sentence. What does it mean? Let's first find some examples of anion that ends in IDE. All right, let's go back to this table. There are plenty of them that ends in IDE, right? Mostly are monatomic anion. For example, fluoride, right? Chloride. And when they form acid, because they carry one negative charge, therefore they can combine with one proton to form an acid. And the name for this would be, we change the ending to IC, right? And add acid. So first we'll do is fluoric acid. And then we also need to add hydro as a prefix. So it's hydrofluoric acid, right? And then you can look at a second example of HCl. This is a very commonly known, right? So it's hydrochloric acid. And you can do the same practice yourself for HBr and HI to see, not BI, but HI to see what their names are. So it's hydrobromic acid and hydroiodic acid. So that is the naming rule number 1 for acid. Okay, number 2 is that if the anion ends in ATE, then change the ending to IC plus acid. In this case, you don't need to add hydro. You don't need to add the prefix. Only change the name of the anion from ATE to IC and add acid. So some examples include, okay, let's see ATE. Where do we have ATE? Here, let's do nitrate ion. That ends in ATE, right? And when it forms ion, it combines one active charge combined with one hydrogen, NO3, and this is nitric acid. And other ATE, let's see. Okay, let's see this one. HClO3, and this would be chloric acid. And then the one next to it would be perchloric acid, right? And this one, we have one oxygen or one hydrogen or two hydrogen here. One or two? Any idea? Anyone? So the anion carry two negative charges. In order to have a overall charge neutral compound, we need one hydrogen here or two. I see someone left comments in the chat. Two, right? So we need two for this and also two for the sulfate ion. And we need three for the phosphate ion. And their corresponding names are carbonic acid, and here is sulfuric acid. And the last one is phosphoric acid, right? Did I get it right? Phosphoric acid. O here, not U, phosphoric acid. So those are for the acid and also how to write those acid. Last rule, number 3, if the anion ends in ITE, then change the ending to -OUS acid. And one example would be this one, CHO2, and this is chloride ion, right? Compared to this one, because it has one fewer oxygen, so it's chloride. And when we have the corresponding acid, we change the ITE to OUS. And then we have chlorous acid. So that is rule number 3. And these are the naming rules for acid. And actually we have covered all of these, but I still wrote them down over here. So after class, you can practice it on your own to write down their correct names. And the answers are provided on the bottom of the page. All right, those are acids. Let's see what we have next. Do we have any questions so far? All right, good. I didn't really cover this table, but this table just summarizes what we have covered over here and give you a good comparison of the names of the anion and the name of the corresponding acid. Okay, I have a question here. So acid, is it an ionic compound or a molecular compound? Is it ionic compound or molecular compound? What do you think? Let's see. Ionic, I see more molecular. Yes, so acids here we have shown so far, they are molecular compounds. And the reason is simply they don't have any metal in their formula. However, different from many other molecular compounds is that when you dissolve it in water, they are going to be ionized into ions. So that is the difference. But still, by definition, they are molecular compounds. All right, let's just continue to next one. Binary molecular compounds. This is a new word. What is binary molecular compound? Simply as what it means by the name, it's just compounds with two elements, right? So the name of the element further to the left in the periodic table is usually written first. And what this indicates is, for example, CO2 carbon dioxide. And we write C first. We always write CO2. We don't write O2C because the rule is that we write the element further to the left in the periodic table first, which is the carbon, right? We'll come back to the exception later. And second rule, if both elements are in the same group, the one closer to the bottom of the table is named first. So when you have this compound, we write sulfur first. We don't write oxygen first because sulfur is further down to the bottom of the table and these two are in the same group, right? Oxygen and sulfur is right below it. Okay, number 3, Greek prefix indicate the number of atoms of each element. That's why we call CO2 as carbon dioxide. We don't write it as carbon oxide because di here indicates the number of atoms of each element. So we have the table here, table 2.6, prefixes used in naming binary compounds from between nonmetals. So mono means just one, di means 2, and tri means 3. So CO is carbon monoxide. Mono means there is just one oxygen. CO2 is carbon dioxide, and di indicates there are two oxygens there, right? Well, we don't have carbon trioxygen, but if we move as we move down, then we have tri for 3, tetra for 4, penta for 5, hexa for 6, hepta for 7, octa for 8, nona 9, deca 10, right? But usually in this class, you're going to see more often mono, di, tri, tetra, pretty much. But as you proceed along to higher level classes, you're going to see these as well. And exception is that the prefix mono is never used with the first element. Therefore, we don't call it monocarbon monoxide. If it is the first one, then we don't need to say mono, just carbon dioxide, carbon monoxide. And here, when the prefix ends in A or O, and the name of the second element begins with a vowel, then A or O or the prefix is often dropped. So mainly this is mono. We don't say monoxide. Then we drop the O and then just write monoxide, right? And another example would be, let's say, let's find an example that we drop the A. So penta. I say if we are going to have 5 oxygens, then it would be pentaoxide, right? But then we don't write both A and O. We drop the A in the prefix and just write pentoxide like this. Last rule, the name of the second element is given an IDE ending. So it's carbon monoxide IDE, carbon dioxide IDE. And here are a few more examples. Carbon, this is tetra, carbon tetrachloride. And this is, now the first element has 2 atoms. Now we need to add the prefix this time. So it's dinitrogen, meaning that there are 2 nitrogen items. And for the first element, we don't change the name. So it's nitrogen, we just write down nitrogen. There are 2, we put down the prefix for di for 2. And the second one, O5, then 5, we find this table that is pentoxide. We have to change the name of the element from oxygen to oxide. So it ends with IDE. And last one is carbon monoxide. So these are the naming rules for binary molecular compounds. There's one thing we didn't cover. An exception here occurs when the compound contains oxygen and chlorine, bromine, or iodine, in which case oxygen is written last. For example, we have, what would you call this compound based on this naming rule? You can write it down in the chat. So we have 2 chlorine, 1 oxygen, Cl2O. How would you name it based on this naming rule? First answer, dichlorine monoxide. Is that correct? Yes? Anyone else? Yes, very good. This is the name of this compound. First is chlorine, right? And there are 2 chlorines. We use the prefix di, so dichlorine. And there is 1 oxygen, so mono, oxygen changed to IDE, monoxide, right? So dichlorine monoxide. And this example is to indicate, although that oxygen is further left on the periodic table, but as this is an exception, we gotta write the chlorine first. But there is also another exception, except any halogen except fluorine. So if it's a combination of fluorine and oxygen, you still write oxygen first, followed by fluorine. So you're going to get something like this. Again, what's the name for this compound? For this binary molecular compound? Difluorine oxide, oxygen fluoride. Now we have more deep. We always start from the name of the first element in the formula, in the chemical formula. So we need to start from oxygen. And if oxygen is the first one, we see oxygen fluoride, monoxygen fluoride, oxygen difluoride, yes. Oxygen difluoride, yes. Okay, so this is a good practice. And start with oxygen, and because it is the first element, so we don't need to write mono. So just oxygen, and fluorine, change fluoride because there are 2, so we use di, so oxygen difluoride. Yes, very good. So we have already covered the most difficult part. Number 6, it's easy. Diatomic molecules, just the name, it's the same. The name is the same as the name of the element. Hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, iodine. It's the same, no changes. The last part, the last page of it, this part, we're not going to test you on the exam, but in the next few chapters, we are going to talk a lot about these compounds. So when I say the name, you need to know what they are. So we introduced two different kinds, alkanes and alcohols. And what define organic compounds versus inorganic compounds? So organic compounds contain CH bond, carbon hydrogen bond. So let me write down here, any chemical. So organic compounds refer to any chemical compounds that contain CH, carbon hydrogen bonds. Then compounds like oxygen or water that they don't have carbon hydrogen bonds, then they are not organic compounds, they are inorganic compounds. And organic compounds, alkanes, are the simplest form of organic compounds because they only contain carbon and hydrogen. And the first, so for their names, here we show a few different examples of methane, ethane, and propane. You're probably already familiar with some of them. So the name is that the name just lists the name just lists, the first part of the names just listed correspond to this sentence doesn't make any sense. But anyways, the first part of their names correspond to how many numbers of carbons that they have. So if you have one carbon, like here, one carbon bonded to 4 hydrogens, then the name start with METH, meth. And then if it is 2 is ETH, and 3 is prop, and 4 is BUT. So 1, 2, 3, 4. And then the second part of the name just indicate what they are. If they are alkanes, then they end with A and E. So methane, ethane, and protein, right? So in later classes, we're going to say what's going to happen with methane, how combustion reactions, for example, how they burn in oxygen, and how propane burn in oxygen. And you just need to have this concept in your mind that what they are just hydrocarbons, right? And for alcohols is changing one of the hydrogen in the alkane to hydroxyl group, which is OH. Therefore, for example, this is methanol. It changed one of this hydrogen right here to OH. And when we name it, we change the ending from A and E to OL. We just change the E actually here to OL to indicate it is an alcohol. So all alcohols ends in OL and all alkanes ends in A and E. And the same thing for this, from this, we change this hydrogen to OH, and then we have ethanol. And from this is propane because it has 3 carbons, and then we change the hydrogen in the end to OH, then we get propanol. Just change the ending from E to OL, propanol. Well, last thing, propanol, another alcohol that we use pretty regularly is, what is it? Isopropanol, right? What is isopropanol? Isopropanol is, instead of having the OH here, we have the OH over here in the middle. And that's a different compound actually, right? Because the bonding is different. And that is called isopropanol, right? Or isopropyl alcohol. Yeah. All right, so these are just some simple examples of organic compounds and their naming rules. But what's really important for now and for the next exam is to know the first 6 sections: diatomic molecules, binary molecular compounds, and acid, inorganic compounds, cation, and anion, right?